Hi, this is Sean, and welcome to Module 6. In a lot of the discussions through the beginning of this course, we've looked at really computational ways of analyzing the electronic trace data that's left behind in learning systems by students who are participating in different kinds of learning activities. And in the course of looking at these different kinds of computational analyses, we focused on network analysis. Also, we have thought about ways that we can design visualizations that can help teachers to identify students who need more or less assistance, and also increase awareness of students, of other students who are perhaps familiar with the same or interested in the same general topics as they are. In this module, we're going to focus on a method of research that is not directly related to learning analytics, but instead informs and draws into question some of the more purely computational approaches that you'll read about when you study the learning analytics literature. As I noted at the beginning of the course, learning analytics in itself is a topic, an area of inquiry that is open to much debate. There are folks who are on the data mining point of view who actually use data mining algorithms to go against large corpora of MOOC or other online course data to try to identify clusters or other purely computational representations of how people are working together. There are others who, like me, try to take a network analytic approach, using the trace data to identify ways that students are learning socially or through their social interactions in an online learning environment. And one of the premises of both of these two approaches is that there is a group of people who is working together, and it's a group of people that's larger than a half a dozen, usually a class size of 25 to 40. A third way that learning analytics is approached is from the individual level. And so from the individual unit of analysis, you have people who approach learning analytics as another mechanism for psychometric analyses or evaluation and placement of individual students into groups or cohorts that represent in some way what I would call a proxy for achievement or capacity. And policymakers in particular are interested in these kinds of bucketing mechanisms that learning analytics could potentially be used for. What we want to talk about, or what you're going to learn about in this module, is a slightly different way of thinking about learning in a technologically mediated environment. And there are two significant differences in this module and the kinds of analytics that we're studying in this module compared with the other modules. First, the interactions that students have in this module, which is largely focused on analysis from the Virtual Math Teams project that I've been a part of for 5 years at the Math Forum at Drexel University, is that there are students in groups of 3 who are participating in the solving of math problems in a synchronous way. So most of what we've looked at so far involves asynchronous, meaning that just as we do in this course, you log in remotely and post a comment, and somebody will log in hours later and post another comment. In the Virtual Math Teams with GeoGebra environment that we're focused on in this module, the students are physically or virtually there in the Virtual Math Teams with GeoGebra environment together. And I've actually added an analysis document from an ongoing National Science Foundation funded project that the math team, the Math Forum at Drexel and I and a group at Rutgers are participating in. And you can see me showing you one page from that analysis in this video. And I want to point out a couple of things, because what we're going to learn about in this module is primarily the ways that conversation analysis help us to understand what's really happening in a learning environment and how students are really experiencing that learning environment. It's my belief that through this kind of detailed study, which is a focus of the VMT with GeoGebra team, that we can gain insights that can be ultimately developed into not purely algorithmic, but more thoughtful and learning outcome-based measures of or learning analytics tools for these kinds of environments. You'll see on the left-hand page a short piece of chat, and around that chat you'll notice that there's a discussion, and the discussion is focused on how the students are identifying shapes in a particular lesson. And if you scan this document, I certainly don't expect you to read it, but if you scan the document, you can see that it's organized by lesson. and that the learning analytics that might emerge from this kind of analysis, or this kind of step-by-step discussion of the conversations that occur in these virtual math teams with GeoGebra environments, could lead to insights about specific sorts of analytics that could be developed. So I encourage you to follow the activities in this module, ask questions if you have them, scan this new document that I uploaded, and engage the discussion. I look forward to seeing you online.